Here are the two functions I gave you at the end of the last video. If I want to find the domain of f, it's a fraction. So again, the rule is that the denominator can't be 0. But that just means that x can't be 3. Whoops, that x can't be 3. So if I were to graph that, that's everything except 3. So it's everything to the left of 3, everything to the right of 3. So the domain of f would be those two intervals, negative infinity to 3, union 3 to infinity. Now g involves a fourth root, and then we're adding 1. Well, the adding 1 doesn't affect the domain at all because that's not under the radical. If I can evaluate the fourth root of 2x, I can add 1 to it. So the rule is just that whatever's under the radical has to be non-negative. So here I need 2x to be bigger than or equal to 0, and that simplifies to x being bigger than or equal to 0. So the domain of g is just going to be from 0 to infinity. Inclusive inequality, so I include that point. Now we're going to find the domain of f times g, and since multiplication doesn't add any restrictions, that's just the intersection of these two. I did ask you to go ahead and find me a formula for f times g, though. So let's do that first. fg of x would just be f of x times g of x. I'm going to come up here. That's going to be 2x over 3 minus x times the fourth root of 2x plus 1. Now here, I can simplify a little bit because this has two terms, so I can distribute that multiplication. Might be helpful to just write this as it's the fourth root over 1, so I can write it as a fraction. So then I get 2x times the fourth root of 2x over 3 minus x, plus when I multiply by 1, I just get 2x over 3 minus x. So notice I did enough of the arithmetic that there was no need to write the parentheses anymore. Okay, now in finding the formula for this, I can still pretty much see 3 minus x can't be 0 because it's still showing up on the bottom. And I've got to be able to evaluate the fourth root of 2x, so 2x has to be bigger than or equal to 0. So often I can see any restrictions on the domain from the result just as easily as I can from what the individual pieces are. We'd already worked out what it was for the individual pieces, so we might as well go with that. Okay, so that's my formula. I'm going to erase it because I just want to work with the domains now. So if I want to find the domain for f times g of f, I find it helpful to graph things. Not absolutely necessary, but I think it's very helpful. So f was everything except for 3. G was everything from 0, including 0, on. You'll notice when I graph this, 0 is to the left of 3. So even though I didn't mark off 3 here, I did make sure to line up my number lines so that places that align represent the same number. Now, in order to be in the domain of f times g, need to be shaded twice. So nothing to the left of 0, because that's not shaded in the domain of g, but starting at 0, 0 is definitely shaded twice, and then everything to the right of that, except for 3, was in the domain of both graphs. So I basically need to have a non-negative number so that I can take the square root, and it can't be 3 so that I can divide by x minus 3. So that would be my domain for f times g. All right, in the next video, we'll start taking a look at the domain for the quotient function. That's a little bit more complicated just because the division introduces an additional restriction. So in order to do f divided by g, I've got to be able to do f, I've got to be able to do g, and I've got to be able to divide. So I'm going to have to double check that the function that I have in the denominator is not 0.